Hello everyone, I'm Sebastian from BigWhoop project, who is participating in this year's NASA Space App Challenge. We did the Air Traffic Tracking Challenge, which is all about tracking aircrafts. We use those cheap SDR dongles to sense everything we can sense in the spectrum which is covered, and this is a wide range of course. Our approach here is a bottom-up approach, meaning that we monitor the whole spectrum and then look at the data that interests us. And do not only monitor the ADS-B data, for instance, which is sent by the airplanes. We can sense multiple kinds of data. For instance, we can see radio at about 100 megahertz in Germany. We can also sense digital radio, which is about 220 megahertz in Germany. And we can also sense things like GSM, which is about the 950 range of megahertz. Our approach is a distributed approach, meaning that everyone who has such a dongle can participate. And also some folks sent over some data, thanks for that by the way. And we gathered some data from Virginia in the US, and we see some spike at around 89 megahertz or 90 megahertz there. And we have no clue what's behind this frequency. So if you have an idea, send it to us via mail, and we figure it out what data is on this channel. Everyone can participate in coding, since we did it in Python, in a very extendable way. And once the data is gathered on your local device, it will be sent over the internet to our servers for further processing. The outlook is an integration into the BOINC network, and where we also have the Constellation project. We also did some research on ADS-B and implemented a small library which is capable of parsing and getting out the data of ADS-B, but so far we did not have enough time to integrate it into our BigWhoop service yet. We also want to track satellites in the future, and we want you to join us and impress us with something that really is cool and matters. So thanks everyone for participating, thanks for sharing your data with us, and hopefully you will join us in monitoring everything we can in the spectrum.